such a popular, pivotal technology. So, guys, what's going on? What's going on? Back with a second episode of learning blockchain. Let's learn blockchain together. So, I'm going to move my face a little bit. We're looking at some software here. This is actually software for a native application. We're not going to be building too much software, I don't think, anytime soon for the blockchain basics, right? Sorry guys, I was just on a meeting and just getting back into what needs to be done here. So let's fire open TeamSyncer, and we're going to go back over where we left off in episode 1. So I'm going to log back into my TeamSyncer account. Again, we're going to use this. This is my SaaS application. We're going to use this to kind of track and nominally progress through the blockchain project here. So I have the blockchain project. Let's actually go ahead and just remove that first project so I can show us doing that by here's my first project. It was some random test build just when I was building TeamSyncer. So I'm going to go ahead and remove it. We'll keep it on the project history for now. That's fine. But we no longer want to have that project associated to this application. So let's just make sure. I have a caching issue, so there's something there that I noticed. So let me actually just delete it all the way out. Then that's fine. We'll just remove it out of this entire project, and we should just be left with the blockchain project. That's all I want to look at. And again, guys, you have free access to this. Go to teamsyncer.com. Sign up. We should be able to get largely everything done with the free service of TeamSyncer. So that's what's going on here, right? So we want to talk about a few things. Over here I have Solana's documents pulled up, and we're going to decide kind of Ethereum versus Solana. I want to cover that in today's episode. The other thing I want to cover is just blockchain basics, like what it is, what's the idea. Like, let's not even look at code. Let's not even talk about software. Let's just build a brief understanding of blockchain basics. So here's Solana's website on blockchain basics, right? And it's a bunch of text. I'm not going to lie, guys. I'm not going to read it. I'm not going to. I'm going to copy it all down, and I'm going to pop it into Chat GPT and say, let's see. Can you summarize this into, let's say, 5 bullet points, right? Boom. And then I'll give kind of my understanding of blockchain, and then okay. So right here we have kind of the first meat and potatoes question we want the answer to. What is the blockchain? Blockchain is described as a decentralized ledger. So think of like a history, like a Google tab where it tells you your history. That's kind of all a ledger is just writing down what happened. Similar to a spreadsheet or an accounting book, storing records and data points. Unlike traditional methods, it is distributed across various computers worldwide, making it secure and less prone to manipulation. So the key word for that, less prone to manipulation. It's an honest system, and that's why we use blockchain, or that's a huge value of it. Is this open database concept, where everybody can access the information if we want to. We can all look at the ledger if we want to. So cryptocurrency and its mechanics. Let's see. Cryptocurrency is a form of currency based on cryptography, ensuring secure, decentralized transactions without a central authority. That's the most important part. So, or a very, very, very important part, right? So if we look at a system today, let's get a fun blockchain-y looking object, right? So this is the blockchain. Or better yet, I'll say this is a bank. And previously, or even currently, this is how, sorry guys, there's a little fly right here. He's asking for his life to be murdered right here, this little fly. So if I'm a customer, right, and and I want to pay for something, right? I pull up my credit card, and basically I use some payment processor, whether it's Stripe, and it goes to the bank. And let's say this is the service or good I want to buy, right, from the business. Even if it's a kid at a lemonade stand, right? If we're in a cashless society, this is how it would go. Is here's Little Jimmy's lemonade stand, right? Or this business over here. We'll say Little Jimmy's lemonade stand. And here's me. I want lemonade. If we lived in a cashless society, this is how it would happen. So you see Little Jimmy's lemonade stand on the side of the road, and you would have to pull out your credit card in this. We're almost there, by the way, a cashless society. So it's terrifying to think about, but you would pull out your credit card, and you would have to swipe it in some payment processor that would ultimately go to a bank or some sort of auxiliary service that holds cash or liquidity for cash, and then we would be able to exchange it with Little Jimmy. And what blockchain is trying to accomplish is I can just directly not do that. I can just go directly to Little Jimmy or purchase directly from Little Jimmy, right? Sorry, let me just say, let's delete it. That was the easier approach. I could just give Little Jimmy cryptocurrency, right? Little coins. Maybe I'll get like a little, here kind of looks like a coin, right? So here's my crypto, right? Whether it's Bitcoin or Ethereum or something. So BTC, right? And I say, here, Little Jimmy, here's a Bitcoin. And Little Jimmy says, awesome. Thanks for the Bitcoin. Here is your lemonade, your limonada. Here you go, mister. Thanks for your crypto, right? So that's how it would work in a cashless society. But the reason why we kind of had banks and a third-party service was for security, like PayPal's, if you think about it, right? Was this kind of central area that they could hold the money to verify both transactions. But what blockchain's doing is we're documenting each one of those steps, right? We're saying, okay, I send Little Jimmy the Bitcoin, and this is getting wrote down on a ledger. So the ledger is up here, and think of this almost as the bank, right? And maybe that's not the case, right? But this transaction of me sending the Bitcoin to Little Jimmy, this gets wrote down into what's a ledger. So Ryan sent Bitcoin, right? And then we need the lemonade sent back. Lemonade sent back. Lemonade sent back. And you're instantly going to say, well, what if I send the Bitcoin and then the lemonade wasn't sent? Well, this would never occur. Believe it or not, there's these things called atomic functions. And atomic functions mean both of these things have to happen for this whole thing to work, right? Both of these things have to simultaneously happen or be executed at the same time in order for this to be documented and verified and validated as a transaction, right? So if either parts of these things doesn't work, atomic functions means it's an all or none. So we could have 10 different functions. We can also, maybe he sends lemonade and a lemonade receipt even, right? And maybe it's also a lemon with the lemonade, right? So maybe it's more than just a lemonade. A atomic function would even mean if he sent me both the lemonade and the lemonade receipt, but he didn't send the lemon, it means it would fail. The whole transaction would fail. So it would undo, and this would go here. This would go back to Little Jimmy, and all of this data right here would never get documented. So boom, it would never be documented onto this ledger. And from my understanding of it, and we're going to dive a little bit more granular of it, but all of this let's say the transaction does go through. So I send little Jimmy the Bitcoin. He simultaneously is going to send me the Lemonade. And the function is going to be in a holding area until that function of both the Bitcoin gets verified that it got sent over and the Lemonade gets sent over, or verified that it got sent over. That's what's going to happen. And then if that all happens, all of this data right here, all of this stuff that happens, the Lemonade receipt, the lemon, all whatever products little Jimmy is sending, all of this gets compiled into, it's ran through a hashing function. And the hashing function, and this is a little bit of a getting granular scope now, but this is what gets data. All of that gets compiled, all secretly, by the way, or should be relatively secretly, gets compiled and then pushed onto a ledger or a block. So that's roughly my bird's eye view understanding of blockchain stuff. And then ultimately, when these blocks get filled up, when Jimmy sells out his Lemonade stand, and there's a shitload of Lemonade out there, we build another ledger for little Jimmy to sell more Lemonade stands. So that's my understanding. That's my bird's eye view of cryptocurrency, of blockchain, of blockchain basics. But that was my kind of lucid chart of it. Let's read through this documentation. Let's continue this, right? So cryptocurrency and its mechanics. Cryptocurrency is a form of currency based on cryptography, ensuring secure, decentralized transactions without a central authority. It's considered safe and difficult to manipulate. Coins like Solana represent value in blockchain protocols. While tokens are built on these protocols for specific projects and functionalities, including smart contracts. Smart contracts and dApps, what are those? Smart contracts are automated contracts coded into a blockchain, executing automatically when conditions are met. So that was kind of what I was talking about over here. When maybe this would also be appropriate to say, here's a little contract, right? Which is saying we need this Bitcoin and this Lemonade before we do anything. Like the atomic function needs it's that all or none thing that I was saying. So let's read some more. So smart contracts are automated contracts coded into a blockchain, executing automatically when both the conditions are met. So again, that's saying the contract would say, one more time, place BTC here, right? This is what the contract's looking for. And then it would also have maybe a little bit more granular, right? Understanding place Lemonade here, right? So we're breaking these high level concepts into more palatable things. So then little Jimmy, he takes his Lemonade, he puts it over there, boom. And then me, as consuming the Lemonade, I say, well, I'll put my Bitcoin right here. And then boom, this is when I'm understanding that this all starts to get compiled into data when those conditions are met. So okay, that's good to granularly or bird's eye scope understand. That's kind of these holding areas, if you will, within the smart contract. So they allow for innovative functionalities that are used in dApps, decentralized applications. So a decentralized application is the same thing as a web application. Let's pull up YouTube. This is how you guys are watching this, is a YouTube, right? So here is my YouTube channel. This is a web application, but it's centralized to wherever YouTube is hosting their servers. A decentralized web application, maybe I'd have some examples, but there's so many scam coins that I had invested in that went left. That I don't know if I can show you guys any examples. But you know what, I can show you Presearch. That's a good crypto. Again, this is absolutely not investing advice in any way, shape, or form. But this is a decentralized currency or network that is acting as a decentralized Google, if you will. So Google has all of its servers in one spot, right? YouTube has all their servers in one spot, but decentralized, you actually get rewarded for Presearch if you host a little bit of their network. So meaning, okay, all the database previously would exist for a company, let's say Google. Let me go ahead and use Lucidchart for this. So let's go to another concept temporarily. So this is how a normal, let me see if we got a song right here to upload it. So this is Google's data, if you will, databases, data centers, all that stuff. But Presearch, what they're trying to do is say, well, we don't want to just exist here. We want to exist on Ryan's laptop, if you will, right? That would be my laptop. So Presearch can have a little bit here. Why is it not letting me press enter? There it goes. Okay, so Presearch data, it's going to exist across the world in multiple areas, in smaller bits, right? So one person downloading this on their laptop obviously is not going to be nearly as strong as the petabytes of data and hard drives that Google has, and all their hardware. So and maybe this is all in the globe, right, of the world. So here's the world, not the word, the world, right? And Google's data exists on like one state, Let me get this layer on top here. So this is where Google's data is, Google data. But the idea of all those databases being compromised is a thing. Now, obviously, in Google, they're not. Google's very secure and smart company, and they actually do have a few different databases across the world. But what Presearch is trying to say is, well, we want a little bit of data, right? Here. It's called database sharding, effectively, right? So you have copies of the data across the world. So that way, let's say a natural disaster happens and it takes out this Presearch database and this Presearch database. Presearch isn't screwed. They can look at this and say, no, we still have data. We still have copies of the ledger across the world. So decentralized application is just understanding that we have some of that open database-esque-ness to it. But mind you, not to badmouth Google at all. Google does have multiple data locations. So there is security with Google, right? It's not just this rink-a-dink company, obviously. So, but let's keep going. So that's what a decentralized application is, or at least one use case of a decentralized project, which are tools for various blockchain-based activities like trading, voting, decentralized finance. We might want to build some sort of DAO, which would be a decentralized autonomous organization. So it'd be a decentralized finance and voting. You would click off two of those things. Web3 and benefits of decentralization. Web3. Let's back it up one last step real quick, actually, before I move to this Web3 point let's revisit that decentralized voting point, right? So we have the world, right? The world in historic terms has faced rigged elections. It's been a thing, right? And that only happens or can happen because there's one authority who can manipulate data, if you will, right? So all this Lemonade transaction stuff, we'll break down the finance version of this as well. But if there's one place that's collecting votes, so let's just say some government, right? Pick the most corrupt company or government in history. I have no idea, but let's say some rigged election of like Nazi Germany or something, right? Have no idea if it was rigged or what. But the only reason why it could have been rigged, if it was because Nazi Germany controlled all of it. They controlled all of the votes, and all the votes existed here. So this idea of a decentralized scope is very common across many things because it can add security. So if we built a new voting system, right, across the world, if this larger circles the world, this one right here, if I make it green to represent the world, Nazi Germany can only get away with a Valve system because they control all the walls, they control all the parameters to it. But when you can no longer do that is when you have a system that says, well, let's reference all of these other systems first before counting the votes. Like, let's count the votes from this voting system, like this voting box. And let's make sure that we have no double counts. Let's make sure that this voting box is good. Let's make sure that this voting box is good, like that we all have the same counts, that we all have the same amount of votes, and that we all, kept track and they all were created at the same time. That's essentially what these decentralized applications are vetting to do, is to say, hold on, before we make a decision, a presidential election, let's just make sure everybody's on the same page. So that's the idea here. Again, in Nazi Germany, the only reason why they're able to get away with it is they're like, hold on, we can lie about stuff, right? We don't have to fact check with anybody. We don't have to reference any other person. We just reference ourselves. Of course there was 1 million votes for the president that we wanted, or the leader that we wanted. Of course there was, right? You have to take our word for it. Of course we did it. We did all the counting. Don't worry about it, guys. Right? So it's good when you have that multi-party, just multi-signature verification, if you will. So let's exit out of that. Let's continue learning more blockchain stuff together. The reason why finances were a part of it was this could happen technically without even voting. This could actually happen in a banking system, to say, oh no, of course we have $10 million in our bank account. If you give your money to a bank and you're like, well, you guys still have my $10 million, right? They'll say, of course we do. But if you now gave your $10 million to this bank over here, we'll say, little bank, right? And this little bank says, okay, I'm going to give this receipt to 10 different banks to double, triple, quintuple check that we have your $10 million, and everybody knows about it. You would always be able to go to this bank. You could actually go to this bank over here and say, wait, you guys still have my $10 million, right? Does my bank still have the 10 million? They say, of course it does. And in fact, you don't even have to go to the bank. You could just be this bank over here. You have a copy of the ledger yourself to say, here is my ledger, right? Here's the bank ledger, right? I know the shapes are a little funky looking, but the knowledge is still here. So my ledger would actually be updated if my 10 million was moved anywhere. So I could track it. I could say, we would update it with every piece of data, right? So all this stuff. Let's see what other songs I could play for you guys. I think we listened to a few of them. We would every time a dollar moved, we would track, say, an object with all the data associated with it. So it would say, the value of the dollar, we would put it in an object. But I won't even do that. We'll say we would track the value. We would track, the date. We would track, the currency, right? The type of currency it was. Was it a US dollar? Was it a Euro dollar? Was it a Bitcoin? We would track who sent it, right? We would also track who received it. So and probably a few other things as well. But this is the idea that we could say, oh, if someone did move our $10 million to, let's say, some scam government, oh, well, we now know that this bank sent it, so we now know, this bank is liable. Sorry, I meant to attach that to my ledger. So we would come all the way over here and say, oh, hey, we saw that you sent this $10 million to this bank right here. Where's my money? You're liable. So we can go to both spots. We could say you're liable for it and you have my $10 million. So that's the rough idea. We know who to get mad at. We know where the money is. We know every piece of data because it's being tracked. It's being nominally tracked everywhere across every transaction. And then we're also tracking that data, and that's where these blocks come from, right? That we referenced over here, where little Jimmy sells out his lemonade stand, and we build out more blocks of data for him because he's running out of blocks of data. But that's a bit on how it could be used for voting, how it could be used for finance, how it could be used for data for Google. So there's a lot of use cases for this concept. But I don't want you guys to look at it as this like big word of blockchain technology and fun terms of Cardano and Ethereum and Solana. Like, these are cool words, right? These are big words. But disassociate from that a little and just say, it's an open database. It's an open database that records all transactions. Let's slide into point 5. Web3 represents the next internet phase, focusing on decentralization. Unlike the controlled nature of the earlier internet versions, this decentralization, offers numerous benefits such as a financial inclusion, reduced transaction fees, enhanced network security, and user participation in governance. Solana is highlighted for its efficiency, speed, and low cost, making it suitable for mainstream adoption and development of blockchain projects. We might use Solana. We might use Ethereum. I'm not sure on the decision yet. I think Solana and Rust would be a really interesting build, but yeah, guys. So this is roughly why Web3 became such a popular, pivotal technology. So. Let's maybe wrap it up there. I think that's a good. Let's see. Maybe we'll set the mood a little bit. But that's a good bit of content, and I think episode 3. Let's dive into something a little more interesting.